Post 33 is the same as this part here. So the other one is x mod 2 does not equal to 0, and x equals to 31, or x equals 28. Are we doing okay so far with this? And then you have to do the simplification step by step. Okay, this is a restriction on top of saying that x can be 30 or x can be 27. X mod 2 equals to 0 means that x has to be even, which means it all simplifies to x equals to 30. Oh, I take it back. I was wrong. This is an OR because we can come from either path. So that's why this is an OR. I had it right up here. I just copied it wrong. Okay. And then the other part, which is this highlighted part here, means that x can be 31 or x can be 28 on the right-hand side, but the extra constraint means that x has to be odd. And x equals 31 is the only case when it's odd, so we can basically simplify that all the way to this one. Are we doing okay with this? Okay. So now, once we know once we have a strong suspicion of what is pre-32, we have to go forward again just to make sure that this precondition will lead to the post condition that we are that we started off with. Okay. So now we go forward again. Okay. When you go forward, the first thing, we can go through the derivations step by step, really step by step this time, because we can say what is pre-32. If you know what is pre-32, pre-33 is based on pre-32 and also the condition of the conditional statement itself. Is that making any sense? Now this one is not, just, guessing it. This is definite, okay? Because we know the structure of a conditional statement, and as a result, we can make all these claims. But that means, we are just saying that pre-32 is x equals 30, or x equals 31, and x mod 2 equals to 0. So x mod 2 is 0 means that x has to be even, which means we are left with x equals to 30. On line 33, the right-hand side of line 33 refers to the left-hand side. The right-hand side has x plus 1, the left-hand side is exactly x, so it's a self-referencing assignment statement. The right-hand side of line 33, this time I give it a name, say f of x, which is x plus 1, has an inverse. The inverse is x prime of x, which is just x minus 1. Because it has an inverse, we can use the substitution rule. When we use the substitution rule, the post condition depends on the precondition, and we have to apply the substitution here. We replace the name of the variable with the inverse function applied to the variable. Okay, do we still kind of vaguely remember this stuff? Okay. So now at this point, you're just expanding everything. You expand pre-32 to be exactly x equals 30. And you expand f prime of x to be exactly x minus 1. So after the substitution, you will have x minus 1 equals 30. And if you apply algebra just one step, you get x equals 31 back. Are we okay so far? Okay. What about the other branch? What about post 34? Post 34, there are two ways to get to line 34. One is post 33, but there's another branch. The other branch is the false branch. So if you go through the false branch, that means whatever was true before line 32 is still true. However, the condition of the conditional statement has to be false. Okay, is that okay so far? Making sense? And then you just go ahead and simplify this whole thing. Post 33 is easy. Post 33 is just saying x equals 31. What about the other part? What is pre-32? Pre-32 is already kind of done all the way up here. That's pre-32. So we'll just copy and paste the whole thing. So we have x equals 30 or x equals 31 as pre-32. And this whole thing has to be ended with not x mod 2 equals to 0. Okay. What can we do about this? Well, x can be 30, x can be 31, but at the same time, x mod 2 has to be non-zero. So which one can we eliminate? X equals 30 can be eliminated, which leaves us with only one choice. So we have x equals 31 or x equals 31. Right? Because the extra constraint here is x mod 2 cannot be 0, which means x has to be odd, has to be an odd number. Out of the two choices here, only this choice is an odd number. And as a result, I can just simplify and say, no, x cannot be 30, x has to be 31. Okay. X equals 31 or x equals 31 simplifies to x equals 31. There's no need to say it again. Yep.
Can we skip the second to last line and just say x equals 31? Or
Yeah, you can skip it. Yep. But I'm just doing it, really, literally, step by step. Now we have to talk about what is pre-35. Pre-35 is post-34 because the two conditional statements are sequential. Okay. Now we can do exactly the same thing here, and analyze, what does it mean to go through the two different paths. So on one side we can say pre-36 is pre-35 because nothing happens between line 35 and line 36. But at the same time, because we are taking the true branch, we also know the condition of the conditional statement has to be true. In this case, x is greater than 30 has to be true. And then you can simplify that because it just becomes x equals 31 and x is greater than 30, which also simplifies to just x equals 31. Does everybody understand why we can simplify this? Where x equals 31 and x is greater than 30 just simplifies to x equals 31. Because once again, we are looking at the intersection of the two. On one side, it's one single point saying that x has to be 31. On the other side, it has many, many points, but x equals 31 is one of those points. Okay. And then after this, we say the right-hand side of line 36 refers to the left-hand side. And then we say exactly the same thing. The right-hand side of line 36, we call it g of x this time. As an inverse function. The inverse function g prime of x is x plus 3. That's why we can use the substitution rule. So that means post 36 is the substitution, the result of substitution applied to pre-36, applied to variable x, and replace x with g prime of x in this case. And then you just expand everything here. So basically we have x equals 31, x, and then g prime of x is x plus 3, okay, just like that. And after the substitution, you end up with x plus 3 equals to 31, and then through one step of algebra, you can tell that x is exactly 28. Is that okay? Just moving forward. But that's not the only way. Okay, going through the then branch is not the only way to get to post 37 because there's also the false branch. Okay. Now I know intuitively speaking, you already know we cannot go through the false branch. But on paper, you still have to say, well, there's a false branch, so we have to analyze, what is the result of going through the false branch. Okay, so we can say the false branch of line 35 means the following. It means post 37 is post 36, or we take the false branch. What does it mean when we take the false branch? When you take the false branch, first of all, the condition of the conditional statement has to be false. But on top of that, everything that is true before line 35 is still true. Okay, is that part okay? This part here represents what happens when we go through the false branch. When we go through the false branch, whatever was true before line 35 is still true because the false branch does not have any operation specified, right? But at the same time, we know that since we're going through the false branch, the condition of the conditional statement has to be false. And that's why I write it down like this. The negation of the conditional statement and the precondition of the entire conditional statement. They both have to be true. But it will get to some interesting result. Okay, the post 36 is just x equals to 28. What about the other side? The other side is saying x is less than or equal to 30, which is the negation of x is greater than 30. But pre-35 is interesting because pre-35 is saying x equals to 31. Okay, so now we have something that is somewhat troublesome because what exactly is that? It's contradictory, isn't it? Because on one hand, I'm saying x is 31, and on the other hand, I'm saying x has to be less than or equal to 30. So in that case, when you cannot find an x that can satisfy both of these conditions, the condition itself is false. Okay? Regardless of the value of x, that condition is false. Cannot be true for any value of x. So what you do is just say the entire thing is false, which translates in programming to there's no way we can be going through that branch. Okay? Let me say that again. Given that x is 30 or 31 at the very beginning, this part of the program will not take place, okay, for sure, because the condition is false to begin with. Anything or false is just that anything back, so now we get x equals 28 back, and that's the end of the answer to this question. Now, students from my other class had said, for this question, the going forward part should be extra credit. And I'll make it extra credit too. That's fine. Not a problem. But do we have any questions about, how we went backwards and then how we went forward again? Logic is okay? Okay. Yep.
You're going to upload this too?
Yep.
Okay.
I'm going to upload it at the end of the day or so today.
Okay.
Okay. So I think we covered it all already. Yep. Yes.
Because we know the second half, like, you cannot execute that branch, could you then deduce that at the very top, since you can never go through, that the x would have to be 30, and there's no option for x to be 31 at the top?
No, x can be 31. Okay, let's think about it. Okay, let's not look at this messy picture here and just look at the pseudocode. Okay, you can actually go through a trace with x initialized to 31, and you can see that the program still works out when x equals 31. But I can just kind of walk through it. If x equals 31, this is false, right? If it is false, I'm not going to add 1 to x, so by the time we get to the end of the first conditional statement, x would still be 31, right? So that means by this time x is 31. If x is 31, x is greater than 30, we'll still end up with x equals 28 at the very end of this code. Yep. But you can see that I don't have to execute a line of code to do all the reasoning that I just did. It's all basically deduction using logic. And with Boolean logic, Boolean algebra applied to it too. Okay. Are there any questions about this one? No questions? How many people then think that as a programmer, as a software engineer, you will never encounter cases where you have to move backwards, in your head, just using logic to deduce the values of variables? It depends on the type of programming you're doing, but many times it is helpful to do it, this way. To be able to do it backwards can be